So the purpose of this video is to provide a method to make handling discrete probability problems a little bit easier. And what I call this the option square. And so with a discrete probability problem, we might have something look like this: demand 10, 20, 30, 40, and its respective probabilities. And with these, we have a fixed ROP. In our example, we're going to have a fixed ROP of 20. So the ROP is going to stay fixed at 20, and the question is, how much safety stock should we carry? Well, eventually, we are going to have to fill out a matrix where we have the various options for safety stock, and we have their corresponding holding costs and the corresponding stockout costs here, and we're going to determine the total of those respective options, how many options we have, and then we're going to pick whatever is the lowest. So we want to get to this, but the purpose of the option squares is to make things a little bit easier to frame the problem and to stay oriented on the problem before we get down here and we do our computations. So let's forget about this for a second. Let's go here, and the first thing we want to do is create an options row or column. And the purpose of the options column is to tell us the options of safety stock that we have, that we need to evaluate. So the way that we create the options column is, the first step is we fix the ROP, and then we're going to take these values and create a little table over here that has 3 columns. And it's going to have 1 row per row. And we're going to take these numbers and put them over here. Okay? So demand, and this column on the right is going to be our options column. And so really, we don't have an option to carry a safety stock over here because we don't need to. So our first option would be to carry the safety stock of 0. That's always our first option. So we're going to put a 0 right here. We're not going to worry about this right here. Now we want to take the 20 and load it here. So we want to take our RP and load it here and here to determine how much safety stock we would carry if demand was 30 and we had an ROP of 20. We have an option of carrying a safety stock of 10 and an option of carrying a safety stock of 20. And so this here is our option column. So we have 3 options to evaluate. That's an option of 0, always. We always have the option of 0. We have the option of 10. And we have the option of 20. That's our options column right here. So if this works for you, to get to that, and then our 0, our 10, and our 20 would go down here. Okay, so that's our option column. Now we want to create an option square for each option. Okay? And the purpose of the option square is really one purpose, and that is to keep us oriented on the shortage per option that happens if we don't have it covered. So here's how we do that. We take our basic table, and we're going to insert in the middle a shortage column. So we're going to take this table demand is going to be here, probability is going to be here, and those numbers are not going to change. 0.1, 0.2, 0.3, 0.4. 10, 20, 30, and 40. Now, to create the shortages, the first thing, again, we're going to fix the ROP. We're always going to fix the ROP. And I like to fix it with a circle. And then we are going to fix the total amount. Now, for the zero option, because we have a safety stock of 0, an ROP of 20, that's here, and so we have a total on hand quantity of 20. So the 20 total on hand is our triangle, and so we're going to put a triangle around 20 because it's the same thing. This will make sense as we create our other option square. Now, what we need to do with the 20 is drop it down, our triangle, here and here. When we drop that down, 30 minus 20 is 10, 40 minus 20 is 20. And these are the two scenarios we need to be concerned about if we choose the 0 option. Because if we have no safety stock on hand, with an ROP of 20 and demand is 20, we don't have a shortage. Nor do we have a shortage if demand is 10. So we don't need to worry about these top two. We need to worry about these bottom two. And what this does is we can go over here to our 0 option, which is our worst case scenario. We can compute the holding costs. Of course, those holding costs are 0. But then over here are values that we're going to take these and we're going to model those scenarios. So we're going to take that 10 and enter it in there, and we're going to take that 20 and enter it in there. So this cell right here would look like 10, and we take its respective probability, 0.3, times the number of times we're going to order per year, that's part of that formula, and the stock out cost, whatever that is, and we should have that given up front. And we're going to add that to that other scenario of 20 times 0.4 plus these two. And these two are constant, the number of times we order per year and the stock out cost. And that value is going to go in this cell right here for our 0 option. Then we're going to add the holding cost plus that value and get this value down here. That's the purpose of our 0 option square. We need to make squares for the other options. So our second option would be our inventory or our safety stock of 10. So we're going to make an option square for that. So I'm just going to squeeze it in here. And it's going to have the same setup as this one. It's going to have 3 columns, 4 rows, just like this one. Our probabilities will not change. 0.1, 0.2, 0.3, 0.4. And our demand will not change. But we're going to put it on the left-hand column so we can do those subtractions to generate the shortages. So 10, 20, 30, 40. This is demand, and this is our shortage column. We're going to fix our ROP with a circle, and we're going to write a title for this option. This is the 10 option, and the 10 option is defined because it's a safety stock of 10, an ROP of 20 for a total of 30. So we're going to mark that 30 with our triangle here, and then we're going to drop that 20 down here. So 30 minus 10, or no. We're going to drop our 30 down here. Our 30 is what we drop down. Our triangle is what we drop down. So in this case, it's 30. So 40 minus 30 generates a shortage of 10. But if demand is 30 and we have 30 on hand, we don't have a shortage. And if demand is 20 and we have 30 on hand, we don't have a shortage. So the only contingency we need to be concerned with is if demand is 40 with our 10 option. So we go to our matrix here with our 10 option. We compute our holding costs, which is 10 times whatever the holding costs are. And for this cell right here, I'm going to write it out here. We're just going to take these two values to start off what goes in that cell. So we're going to take our 10, which is our shortage. We're going to take our 0.4, and we're going to take the number of times we order and the stock out cost. And that value is going to go back in that cell. And then to determine that total, we're going to take this product with that sum and get this sum out here. So that's the purpose of our second option square. Now, the beauty of this technique is with the third option square, it's a ghost square. So our third option is 20. Well, let's think about this. If we draw the option square for the 20 option, we're going to have everything covered. That's what the 20 option does. The 20 option has a safety stock of 20, an ROP of 20 for a total of 40, which covers every contingency in the table. So I call this the ghost square, meaning this will be 0. But if you want to do a square, you can do a square. I call it the ghost square just to have a placeholder. With 3 options, I want to have 3 squares. I have one square here that tells me my shortages and those respective probabilities of those shortages. I have my second square here, which tells me my shortage and the respective probability with that shortage. But I don't need a third square. I just have my ghost because that's my placeholder. And that's going to be 0. This is going to be 20 times whatever the holding cost is. And so that will be 20 times whatever the holding cost is. So to recap very quickly, the option square is just a tool to make discrete probability problems potentially a little bit easier. The key to this is fixing the ROP, identifying the safety stock options up front by creating a safety stock options column. We do that by taking demand over here and subtracting by that fixed ROP to get those 3 options. And then we create an option square for each table. And the key to the option square, the whole purpose, is to identify the shortage per the scenarios that we don't have covered with the total amount that we have on hand. And we do that by creating a shortage column in between our existing discrete probability table specific for that option. So as you see, you can't repurpose because these values will change. These shortage values will change because you'll have different amounts on hand. So you need to create a unique option square for each option. And then you have a ghost square at the end just as a placeholder. But you might try this out the point of this is to not make the problem more complex. It's actually to do the opposite, to make the problem more simple. So try it out. If it works for you, then great. Give me some feedback if it helps you out. If it just makes it more complicated, then I would abandon it, and I would get down here and focus on what you need to do to get the right values in here to solve the problem. Obviously, when we have values out here, we want to select the lowest total value, because that value gives us that average of holding and stock out costs, which is what we want to do with safety stock and any inventory for that matter. Thank you.